Guys, welcome to part 3 of benzyne intermediate and benzyne mechanism, part 3 basically. Earlier two parts I am sure you have seen. If not watched, please watch those parts, and I'll just take you to the review of the last one. We have formed these kind of products with 4+2 cycloadditions, and we have formed these kind of products with DAR reaction, and we have also done dimerization and trimerization in case nucleophile is not present for benzyne. But normally what benzyne does? Benzyne normally does substitution. And what is the substitution formation which is possible? It goes to the next two positions, and in case we don't have open positions, we will not form the product. So we discussed everything in earlier videos. Just watch those. In this one we will talk about few more reactions of benzyne. So one of them is, if benzyne is given and benzyne is reacting on compound named furan. So what is the product? Let us see. This is called furan. So what we can expect? So benzyne we can take as a diene, and the other thing is a dienophile, and we know what we do with diene and dienophile system. So what you can do is you can draw the whole structure like this for your convenience. So it's like this, and you can again copy the whole structure like this. See what I'm doing, and keep oxygen part like this so that you don't worry too much about oxygen part, and you can easily do the reaction with 4+2 cycloaddition scenario. So what is DR reaction? In DR we say diene is given, dienophile is given, so this will attack here, this will become double, and this will attack here. This is again example of 2+4 addition, cycloaddition. So what is the end product of this whole thing? You can draw the ring. First ring is as it is, this will remain only double, this is connected here, and this place we get a double bond at this place, and it is having connection of oxygen. So they may draw like this, or in some books you may find that they have drawn it like this also. So both are correct options. You can draw it like this, or you can keep it like this also. Okay, so both are correct, but we prefer this structure to be drawn. So this is a reaction of benzyne again, and let's proceed further to see some more reaction. Now write down, benzyne reacts with alkyl or aryl lithium to form aryl metal compounds. So we'll see this reaction, what is meaning of it. Note down, the next case of reaction would be benzyne reacting on alkyl or aryl lithium. Aryl lithium. So what kind of reaction we can expect? So let's say we have benzyne and we are taking C6H5Li to come and do the reaction with this. So what kind of reaction it can be expected with C6H5Li? C6H5Li as an RLi is a C6H5 minus Li plus, and you know that C6H5 minus can be attacking at this place. So when it attacks at this place, what will happen? This will join at this place basically, okay, and the minus charge will accumulate at this place, which will go for Li plus, which is still available in the process, right? So when you do this, you have eventually C6H5 and Li at these places, and double bond will be like this. So please draw the structure, LiC6H5 like this. And if this particular compound is given for any further reaction in presence of, let's say, carbon dioxide, okay, followed by anything like H plus, so what will be the product of this? So we have this minus Li plus, this part is your new aryl lithium. I repeat, this part is your new aryl lithium, because if you observe this part, what is it? It's a C6H5 ring connected on another C6H5 ring. So it is connected on another C6H5 ring like this, and connected on Li at the next position. So it's the first joining is here, let's say joining is here. So I'm just putting some color so that you can observe. This is the color red one where this is joined. So which position is Li? The next position is Li. So you can say Li is somewhere here maybe. So this kind of compound, if you react it with, as I mentioned here, let's say you react with CO2 and then try to hydrolyze it, or with H plus you try to react it, can I say this is a C minus part, and this C minus is willing to attack here. So what kind of answer we can expect? We can expect that pH is joining on the ring, and the next position we get CO minus Li plus, and with provision of H plus as mentioned here, it can become pH hanging on this position, a ring, and this is a COH. This kind of result we can expect. So this is your final answer, which is we can say it's a biphenyl 2-carboxylic acid, right? So you can draw these kind of answers. Now the next reaction is, in certain cases where synthesis of heterocyclic compounds can also take place. So that's also benzyne. See how big is benzyne? Synthesis of heterocyclic compounds. And these things are very useful for any exam of chemistry starting from standard 11 till MSc. You will be using these things, and for different examinations which you're preparing for, you can always refer these videos. Okay, we have many more in lineup, so you can just refer the previous one or what we are going to record next. So I hope that you like, subscribe and share these videos and refer to your friends also. Next is, let's say we are taking this example. This example is a synthesis of heterocyclic compound. So I'm just taking a special example, C double bond S, C6H5 kind of compound. Now, step 1 would be, if you see NH is at this place, right, and this is a Br here. So what we can do, the first step is that in the presence of base, this H can be taken, and in the presence of base, this H can be taken, and the whole thing which is drawn here can be written like this. Please draw this. I'm writing N minus in place of this. The reason you understand, because H is gone, and at this place we can say N minus, and then we have C double bond S. So later it is C6H5, and we can send it here to make it stable. So we can say this can take a format of this kind of structure: nitrogen, double bond, CS minus and C6H5. First draw the structure. So what is the next step? In the next step, this S minus can go and attack here, and later this will be negative and it can be given H plus. Which H plus it can be given? The H plus which base has taken in initial level, which has formed BH. So what's the answer? So final answer could be, after exchange of H plus and all, you can say this is now, let me put the double bond in the right place. So double bonds are here, 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 and then this is N double bond C connected with C6H5 connected with sulfur, which is connected with this ring now. This kind of structure we can draw, and once you complete this structure, you can say this is a benzothiazole kind of compound. So note down, it's a benzothiazole, and this is a 2-phenyl location. 2-phenyl because of this position. So it's a thioazole group and 2-phenyl location. So like that we can draw different other products also. I'll take one more example for heterocyclic formation. So you can just take this example. This time we are drawing the structure as Cl at this place. We have CH double bond N, and I'm keeping a ring here, C6H5 ring. A reaction is happening with KNH2 in liquid ammonia. Okay, so normally this there's a small confusion, like whether there's a Birch reduction or something. So always remember, in Birch reduction you use sodium liquid ammonia and all those things, right? Or lithium liquid ammonia. This is KNH2 liquid ammonia. So what is the next step? You will try to take this Cl and try to create that benzyne thing. So which is the right place to grab hydrogen? Only one H is available for us. So you can go grab this hydrogen, create this thing and send it out. Okay, so fine, all of you understood that this can be drawn like this, and this is a bond which is drawn here. This is CH double bond N, and this is a pH ring hanging on this place, right? This is the first structure we have drawn. What is the next step which we can take? So in the next step, we have drawn everything up to this. Now, if you count members, this is 1, 2, 3, 4. It is not successful to close a 4-member ring, so we'll attack on 5th member. So 5th member ring attack is a feasible option. And if you do that, if you can do that kind of attack, what will happen? You can start clubbing the structure with the other one. So let's try to draw what could be the final answer in this case. So you can say it will be eventually, if you draw the proper structure right, it would be taking this kind of shape. Please draw. N is here, and we have double bond here, here at this place, and we have connection of, please check, this is double bond, so this is double and this is double. We must get this kind of structure after final. So this is